and now we're being recorded. So the other numbers here, the World Health Organization has not been as clear about these guidelines, but these are guidelines that the Ohio EPA has laid out also for recreational and drinking water for the neurotoxins, anatoxins, and the saxitoxins, and then another hepatotoxin called cylindrospermopsin. We have seen all of these toxins in the state of Ohio, and if you're wondering how much we should care about that, this slide kind of gives you an idea relative to some things that you've probably heard of, like ricin and cobra venom. And if you're not familiar with the unit LD50, the upshot of it is the lower this number is, the more toxic something is. So you can look at some of these neurotoxins and recognize that they are as toxic as some of the nastiest bioweapon agents that we consider in this country. So these toxins are serious stuff, and the impacts of them are very serious stuff. This is directly out of a paper that was published at the end of 2013 by a team at the CDC led by Lori Backer. I can send that paper to anyone who wants it. And they just combed the literature and were able to confirm 368 dog deaths, but of course they contend that that is probably a very small fraction of what has really occurred over the years. You may have heard about the elk deaths in New Mexico just last summer. They now believe that is due to anatoxin poisoning. Livestock deaths occur every year. This is the actually famously called Wayne Carmichael cow. Wayne Carmichael, who is a consultant for Beagle, took this picture, I believe it was 1979, with anatoxin. This is still happening almost as frequently today as it did back then. And this is a migratory bird at Poplar Island. Pete McGowan shared this picture with us. They have major bloom issues at Poplar Island. So this is a pervasive, widespread issue that is intensifying with climate change and intensified agriculture. And when we started Beagle, we started with the question of, this, in my mind, this is a natural disaster, and I don't see it going away anytime real soon. The question is, can it actually be a natural resource? Can we turn this problem into something positive until there is a cure for the problem? And then you have to say, well, a resource for what? And just looking back, part of the reason we were thinking this is I've been growing algae for a lot of years now, and I did never get it to grow this well. So the question is, why would I grow, tens of thousands of gallons of stuff when there's so much of it out there? And the real issue is, what do you want to use it for? Of course, everyone, for a few years, I think people are kind of having some change of heart on this, but for several years, the big idea was biofuels. And the thing for me to reemphasize here is that the algae I'm talking about in these blooms really aren't the same algae that people typically would grow for biofuels. I wouldn't say they're a complete non-starter for that application, but there's certainly a lot of R&D to be done before that can be realized. I don't know if it's a good idea for me to try to package chlorophyll or other nutraceuticals from toxic algae. We can purify the stuff, but it gets very expensive. It's not very cost-effective to go that route. However, I was aware of a need for a certain class of biochemicals, and that is actually the toxins themselves. So it ends up that there is actually a community of people that need purified toxins. These are folks like analytical chemists that monitor harmful algal blooms, people that manufacture detection technologies for harmful algal blooms, the people that come up with those LD50 data. They have to have pure toxins to do those animal studies. And on and on. There's a group of scientists in the research and regulatory communities that I knew were not getting these products at the level they needed. There was just a classic supply-demand issue for these products. So we thought this would be a good place to start. I probably probably have some regrets now about calling this low-hanging fruit because it ended up being a lot harder than I thought it would be. But in the end, where we are now is we actually have a patent-pending biorefining process where we can take that biomass that we collect from a harmful algal bloom and take it through a series of extraction steps and refine out multiple products. What I'm showing you here is one example. We actually have many other products we're learning to purify as well. But this is an example of how I'm getting at least 3 products, phycocyanin, microcystins, and chlorophyll A, which I can sell as analytical standards to a variety of people that need them. So let's talk, well, there it is. Let's talk then about how we get to that biorefining in the first place. What does Beagle actually do? The first thing we have to do is find the harmful algal blooms. Now, you would think that's easy, since Lake Erie seems to be doing this all year long, but it actually ends up to be a little more of a challenge than you would imagine to find the right algae at the right time and then implement the field operation to collect that material. And then, of course, on a parallel path, we had to build a lab operation to support these activities as well as become the place that houses our biorefining concept. So let's talk a little bit about harmful algal bloom identification. And I think that this demonstrates one of the reasons it's not as easy as you would think. To the naked eye, these both look like harmful algal blooms. But this on the left is a non-toxic strain of an organism called Oscillatoria. This on the right is our favorite toxic strain, Microcystis aeruginosa. You can't just look at these and take for granted that it's going to have the products you want. And I have to confess, we got burned on this once. We collected a lot of algae at one site that we thought was Microcystis, and it wasn't. We still got some stuff out of it, but certainly not what I was going for. Innovations are, I'm going to show you, my system for collecting this algae includes a 10,000-pound van. So here's a picture of it. I can't just drive this thing up to the beach. We have to be able to put this someplace solid within 100 yards, within a shoreline. And we've developed what we call this Blue Mobile, which is a wide-base sprinter van. It self-powers, so we can run the whole thing on a generator. And we have an instrument called an Evidose Type 10 that we use, in effect, for centrifuging that algae that we pull out of that lake. We have many other support pieces of equipment that allow us to basically skim algae off of a lake, pump it through the Evidose Type 10 to dewater it. Then we put it into 2-gallon buckets, and we can flash freeze it on site. And then we can store it for a very long time and transport it back to Columbus. And putting all those pieces together, you know, you've got to find a way to transport a couple hundred buckets of stuff back to Columbus. And you have to find the freight forwarders and the way to keep it cold. And there are a lot of logistical aspects of this field operation. So this field operation is how we go out to a harmful algal bloom and collect the stuff. I want to talk just a bit about that Evidose centrifuge that we use. First of all, I'll take a moment to thank OBIC. This was actually purchased through Ohio Third Frontier Fund. So this is a piece of equipment that we can use rate to all OBN members, and you guys should be aware of this because I've used lots and lots of centrifuges over the years, and this actually technically is not a centrifuge. And this is one of the most rugged, easy-to-use pieces of equipment I've ever had. You can use it for virtually any type of solid-liquid separation, and its key features are very low energy demand. You know, if any of you have ever used a disc stack centrifuge, you know that I'm not going to be putting that on a van and taking it out there and running it very efficiently off of a generator. I can do that with this piece of equipment. But the other thing is it doesn't damage the product. It doesn't damage the cells. And since my toxins that I'm trying to isolate are intracellular, that way the toxins are not being released into the water that I'm discharging. So it's very good for me to have that low shear force in what I'm doing. We love this machine, and I just want the network to be aware that we can make this available to you. The other interesting thing is Evidose is so pleased with our mobile platform that we are now the U.S. agent for this technology if anybody wants to try it out for their algae operations. So what we do with it, here's an example of a deployment that we did in October of 2012, and these are 2-gallon buckets that typically will contain anywhere from 12 to 18% solids. This gives you an idea of the amount of material we can collect on a day-by-day basis. We used to think we were going to need tons of material. We've since come to learn that, as in most things in life, quality is more important than quantity. And using our dewatering platform, I'm showing you here basically a moisture content analysis of 2 feedstocks that we collected from 2 different blooms at 2 different sites. You can see here on the left that this one has kind of a green, pasty appearance, and this one on the right has more of a brownish, grainy appearance. Now, the purists, actually they're not purists, a lot of folks really emphasize percent solids as being so important when you're doing a dewatering. I can tell you as a biologist, percent solids is convenient to look at the efficiency of dewatering, but it really doesn't mean anything about the quality of your material. And this material on the right had a percent solids content that was almost twice of the material. It had a product content that was much lower because the ash-free dry weight was far different than what we had here on the left. So getting higher quality material and making sure that your dewatering technology selects for the higher quality material is certainly something you need to consider in the type of operation we're doing. Of course, the most important consideration is, are you getting any product? And I'm showing this is for that same deployment that I was showing you dewatering data for. So we can do kind of quick and dirty measurements in the field, on our field samples, to get an idea of whether the toxins we want are there. And from that same deployment I showed you, we estimated that in all the buckets we collected on that deployment, we had over 700 milligrams of microcystin. Now, a harsh reality of biorefining is that percent yields can be very, very low. If you just do a rough calculation and we look at what we typically sell microcystins for, what the prices are per unit, even with pretty poor recoveries, on that trip that we took, we would still get a 2-fold return on investment if we only recovered 20% of the toxin that we collected at the lowest price of toxin that we sell. So this is actually pretty efficient to go out and do this field operations because I can get so much more material than I could ever get growing it myself. And it's high quality material as long as we've been very selective about where we collect it. So that was a quick push through the field operation. I'm going to tell you a little bit more now about that lab operation. And I've already showed you this slide, but I want to talk to you a little bit more about the products and why it is we're isolating these products and how this process has led to kind of rethinking Beagle Bioproducts. You know, when we started, our plan was to sell these microcystin toxins. And what we learned was that, one, that market was very small. But the other is when we were going out there doing these field operations, the people we were working with needed help. They didn't really care about these products. They cared about, can you tell me if my water is toxic? Is there anything I can do about this problem? Is there anything I can do to monitor this problem? I'm not a scientist. And we really started to understand that these products needed to be used in different ways. So the phycocyanin, for example, Beagle is the first company to develop phycocyanin in a way that it can be used to calibrate an instrument called a fluorometer. This is a handheld fluorometer that you can actually take to a harmful algal bloom site, and you can monitor the pigment phycocyanin. This exemplifies that the more phycocyanin you have, the higher the optical density of a Macrocystis aeruginosa culture, demonstrating that when you're measuring phycocyanin, which is unique to cyanobacteria, you can use that as a way to monitor the growth of cyanobacteria or the population in a system. So this is a tool that we can provide to people through one of our normal products so that they can start to kind of monitor harmful algal blooms on their own and then decide if they want to hire a scientist who's going to use our pure microcystins to measure the toxins in their water. The microcystin products we make, we get them to over 95% purity. We do use an independent laboratory for quality control, and we generate all the documentation that's necessary. This, for example, is showing a mass spec analysis of microcystin RR that we purified in our laboratory. Chemists use this for monitoring toxins, but some of those people that we needed to help really needed other services to help monitor toxins. So we are going to be adding other products, including the toxins cylindrospermopsin and nodularin. We're going to be adding another calibrator for those fluorometers for the pigment chlorophyll, which are also found in cyanobacteria as well as all the other green algae. But what Beagle is really trying to do now is establish what we call a harmful algal bloom marketplace, where the bioproducts, the phycocyanin, the chlorophyll, the microcystins, are actually just one piece of our larger business model. Because what we really want to do is provide a suite of products and services that help people live with harmful algal blooms. So we've developed this model that people need to be able to monitor, in some cases identify the algae, they need to be able to measure the toxins, and actually a lot of people want to be able to manage the harmful algal bloom situation at their site. So we have products now that fit into each of those suites. You can find them online. We have a very robust e-commerce site that we call the Harmful Algal Bloom Marketplace. And these products give everyday citizens, you don't have to be a scientist at the EPA or the USGS to come up with a way to deal with this. We can provide people with tools. We also can test for the toxins for them and provide that as a service so that they can learn to live with harmful algal blooms. So that was a quick run-through of how we are developing bioproducts from a natural disaster that we view as a natural resource. And after the next talk, I'll be happy to take any questions about what we do here at Beagle Bioproducts.
Okay, thank you very much, Stephanie. I would like to now introduce our second distinguished speaker for the afternoon, Mark Randall of T2 Energy.
Oh, I'm sorry, me.
Philip is, sorry. Just keep going. Mark is the past president and CEO of Quantum Remediation, an engineering service company that processed over 500,000 tons of oil-contaminated soil and sludge throughout the U.S. Was also president of Enviro Insure, an environmental service company that used Mark's patent-pending technology to minimize environmental exposure at dry cleaners, a process that is still in use in many dry cleaners in the U.S. today. Mark graduated from the Rochester Institute of Technology. With that, I'd like to go ahead and turn it over to Mark Randall.
You have control, Mark?
I can move my mouse, but I don't see
Go to the little
my
arrows on the left side.
Yes.
Yep.
And move your Click on it.
There we go. Perfect. Thank you.
Okay.
So thank you to Max, Denny, and Ron for inviting me to give a quick presentation on algae overall, and more specifically the things that T2E is working on that are pretty innovative and very forward-thinking. So why algae? I think as Stephanie has alluded to, it grows, has the ability to grow very rapidly and oftentimes in places and times that are not the most desirable. But there's a growing industry, as we're seeing, where research facilities, research universities, companies are starting to advance on a larger and larger scale of trying to figure out a variety of commercial products for that algae can benefit with. We'll discuss some of the strains. We'll discuss some of the products that are available. We'll discuss one of the, which may turn out to be a very highly beneficial use of algae, which is to sequester CO2. And then we'll discuss some of the things that we're working on relating to biofuels and fossil fuels working arm in arm together. So why algae? Algae has demonstrated that it can be used for food, pharma, nutraceuticals, cosmetics, fertilizers, pollution control in wastewater treatment plants, for instance, and for a variety of energy. So when you look at food, for instance, we were approached in December after I spoke at a conference by NASA. They saw the presentation, they saw what we were able to do, and one of the things that NASA is looking to achieve is to be able to grow food in outer space, and the first step would be on the moon. So they gave us a report of different materials that are on the moon, and as coincidence would have it, many of those are things that we can use to grow algae in our patent-pending algae grow tank system. EPA DHA is the omega oil market is an obvious one for omegas, or for the algae world, as well as antioxidants. In the cosmetic area, algae products and bioproducts are used for moisturizing. Anti-aging is a growing industry. The algal itself presents a high level of nitrogen, phosphorus, and potassium that works in the fertilizing industry. We briefly touched on the pollution with wastewater treatment plants and energy. So this next photo is Earthrise's facility in Southern California. If you can make the background focus on that, that is the Salton Sea, the mistake that was made when they built the Hoover Dam. But you can see in the forefront outdoor growing ponds, and this one in particular is growing astaxanthin, a popular antioxidant. Another company that is getting good press, publicly traded, and doing very well is Solazyme. Solazyme uses a lot of stainless steel for fermenters, a lot of sugar to grow algae, and their market is to go after very high value derived products from algae. We looked at the Solazyme model, and one of the easiest conclusions that we came up with was there was no way that you're going to be able to use the Solazyme system to do any sort of utility size project to capture emissions and at power plants and use that as a source for transportation fuel. Another company based in San Diego is Sapphire, market cap of about $1 billion, and their whole game plan is open ponds near the equator using indigenous algal strains that have the propensity to produce high quantities of oil and then to send that oil through a typical refining process that you would send a fossil oil through. The one company that's probably most similar to what we're doing is a company out of Australia called Algae, and Algae has been using these cargo containers, as you can see, as small photobioreactors. Each cargo container would hold about 20,000 gallons, and they've been successfully taking emissions from a high sulfur coal power plant in northwest Australia for about the last 2 years with 20 cargo containers, and about 4 months ago they announced that they're increasing the number of containers to 200. The interesting things about this model, and we've been following them very closely, is the fact that these are pretty small batches when you look at the overall goal if you're trying to use algae as a filtering system for flue gas emissions. Their 20 to 200 cargo container increase is less than 1% of the emissions coming from that power plant. Some other interesting algae concepts, processes, the one on the left you can see, obviously a cold climate since there's snow on the ground. They're doing high vertical grow tank systems. Not sure where they're getting their light from. And then the one on the right, I think, is a very forward-thinking building design where my guess is they want to use the algae to offset energy costs, as well as some insulating properties that the PBRs may provide the building itself. And then what we've been working on is a entirely closed-loop system where we build our photobioreactor in a three-dimensional manner. So what you would see at one of our facilities would be similar to any sort of an industrial building that you would see in any medium, large-sized city. So our methodology, the goal of what we're trying to achieve is to be able to produce products that are on par price-wise with fossil fuels, but at the end of the day, because of the way we do our growing of our algae and the system that we put it through, it's a more pure and, in many cases, a far superior product. So our goal is to use power that's given up freely at power plants, both in terms of the flue gas as well as the blowers that are used to take the exhaust from the boilers that then blow the exhaust up a very large stack and disperse into the atmosphere. It's a lot of energy that we're able to capture to get us to that number at the bottom of the screen where we can produce a gallon of drop-in fuel for less than $1 anywhere in the world. So the ways that we're able to do that are basically divided into two. One is we have a patented lipid trigger that was validated by a number of sources. Probably the most famous in the algae world is Steve Mayfield, who runs the Center for Algae Biotechnology at UCSD. Oh, there we go. Let me go back. We were a little aggressive with the keys. So our lipid trigger, when we did the testing with Mayfield, we were 15 times greater biomass, 10.5 times more oil in an apples-to-apples comparison over a 7-day period with his best. And the oil that we're producing, 85% of it is in the C16, C18 range, C16 being diesel. And what was interesting about the oil profile on our transportation oil we produced is it was almost identical to canola oil, with the exception that we have less saturated fats than canola. Our system uses a mixotropic approach. So in this three-dimensional deep algae grow tank system, we use LEDs dispersed throughout the entire volume so that in a typical day you'll see a bell curve of sunlight based on sunrise, midday sun, and then sunset. And what we're able to do in this environment is to keep midday sun for a 20 to 22-hour day. And the only time that the algae will convert CO2 to O2 and produce oil, produce lipids, is when photosynthesis is occurring. So what we're seeing in this next slide is a size comparison of being about 20 times larger than what this is a competitor that is doing something similar. They're out of Hawaii. And if you'll notice, just from a pure size perspective, our algae is much bigger and fatter. And if anyone's ever been scuba diving, if you're a smaller person, you'll go through your air tank much slower than the person who may be larger than you will. And this is a great example of, we like big, fat, large algae. The larger it is, the more CO2 to O2 conversion that occurs and the more oil that's produced. So here's an example of what our oil profile looks like. And if you'll notice, in this oil profile, we've really isolated usable products. So the C16, again, being a diesel fuel. C18 has been getting a lot of some particular individuals, companies. So one company based in California wants to use our C18 oil to make a product called 612 vinyl, and the largest user of that product is manufacturing carpeting. Another company that we're in discussions with is a company that's able to take the oleic acid of the C18 profile and bond the two oleic acid molecules together to make a C36. C36 is motor oil. And what's interesting about their process and the product that they produce is it far exceeds both fossil oil and synthetic oil in minimizing wear and tear on the engines. So we just addressed some of the biochemistry, bioplastics, biolubricants that are available from this raw material. We're also working with a company out of Seattle called Macarius Biofuels that has licensed patented technology out of UC Davis that can take our outer shell. So if you remember back 2 slides where we showed cell wall versus oil, the cell wall has great properties that lend itself to feed for livestock. It's great biomass, but also using their acid hydrolysis process that they patented, we can use that biomass and produce C8 and C12, C8 being gasoline and C12 being jet fuel. So how do we grow our algae? And I think this is an area that really differentiates us. And it differentiates us because we get to control every single variable. Our lipid trigger is actually nutrients that are derived from a variety of waste products. So our cost of feeding the algae, if we were just going to go with a straight food-based approach, works out to be between 6 and 8 cents a gallon of our less than $1 a gallon number. We grow a monoculture. So what Stephanie was talking about, and you saw some of the photos where different blooms in the same water area, they're fighting. They're fighting for sunlight. They're fighting for nutrients. They're fighting for everything that they need to survive. And for us, by having a monoculture, we get to eliminate parasites and contamination and control every single variable. And in doing that, we get a much higher throughput, very predictive, and very factory-like. So one of the questions that comes up is energy. So some of the photos we looked at earlier, one of the key components of algae thriving is it has to move. It doesn't like to be stagnant. So what we do is, in our design, we locate near a power plant. It doesn't have to be next to it. It just needs to be near it. And depending on where we're located, It'll be between 25 and 50 feet below ground surface that we'll be building our grow tank systems. We put in the LEDs, so we extend the photosynthetic day. We use a lot of the energy, for instance, the energy that blows the flue gas out the stack. That's part of the energy that we get for free, that with a patented ballast tank and grate system, we're able to stir the algae and the water and the CO2 from the flue gas and the nutrients so that the algae isn't fighting. No matter where it is in that three-dimensional algae grow tank system, it has everything that it needs to thrive and succeed. Depending on where you are in the world, some places have a price for CO2. In California, where I'm located, the latest auction price on our cap and trade program was just over $11 a ton of CO2 emitted. When we look at a comparison of what others are doing to what we're doing, one of my board members is the former president of the University of California system. His name is Bob Dines. I brought him to a presentation that Sapphire was putting together, and you look at open ponds and you look at what they can control and what they cannot control, and the only thing that they can control is what they're adding to it. So whether it's nutrients or Sapphire did a deal with Windy Gas out of Germany, and they're adding bought CO2 to their grow tanks or to their open ponds. But other than that, they control nothing. They don't control weather. I'm sitting at in a hotel in LA right now, and it's been raining for the last 24 hours. Algae isn't very productive when it rains. They can't control temperature. So the facility that I showed you of Sapphires is located in New Mexico, about a quarter of a mile from the Mexican-New Mexico border. In the winter months, they close down. It's too cold, the algae doesn't work, and they're not producing. They don't control pH. They don't control parasites coming in. They don't control evaporation. In an open pond system, the fresh water evaporates, and you get a higher and higher level of brackish water, higher acidic, things that may not be the most optimal to grow algae. And in our closed loop system, by controlling everything, we, for instance, use about 3% water per day, and that's use versus lose. That water is used in the photosynthetic process, and that's where the hydrogen comes from that the algae is using and storing with the carbon that they're inhaling to make the hydrocarbons or the carbohydrates that are the lipids. I'm pressing buttons.
Reset, Mark, or you need to...
You okay?
Well, I'm stuck on this slide. I'm trying to advance the slide, and I am not able to for whatever reason. And I don't know if it's my...
There you go. You're right where you should be.
No, I've got... It looks like I've... Oh, there we go. There we are. Oops. Okay, there we are. So this is a schematic of our first at-scale utility project that we're working on. It's located in Southern California. It's adjacent to a 54-megawatt power plant, and the design of that system is predicated on the 500,000 tons of CO2 that the power plant emits on an annual basis. So this power plant will provide that 500,000 tons. We'll process that through an aggregate 12 million gallon algae grow tank system. It'll be 6 2 million gallon cells. And some of the things that are different about what we're doing with our algae versus what others are doing in the industrial and commercialized space is our algae gets so big and so fat that it sinks to the bottom when it's ready for harvesting. And we don't have to be disruptive and air sparge and push the algae to the surface to skim it off the top. It naturally sinks to the bottom for us. So what this facility will do is it'll be 60,000 square feet on the surface, 25 feet to the ground because groundwater is at 8 feet there. The excess dirt we take out, that will be used as a berm, so we won't go down 25 feet. We'll probably go down about 10 feet. And the 2 million gallon algae grow tanks that are attached or are connected to the power plant, we're pro forma-ing, and that number seems to be getting better and better. About 3,200 barrels a day of gasoline, jet fuel, and diesel will be produced at that facility. And our cost to produce that is about $27 a barrel. So when you start thinking about the efficacy of this as a business, and there's a lot of articles in the news recently about the price of natural gas going up. Oil is about $102 a barrel on NYMEX, and the cost to, if you watch the Sochi Olympics, one of the things the Russian economy needs is a price per barrel of above $80. Otherwise, their economy goes into the tank. The cost to extract oil out of the Bakken oil field is somewhere between $60 and $70 a barrel. So another example, you look at the Alberta tar sands, it costs them about $80 a barrel just to get the oil to the pipeline. And what we're demonstrating and what we're working towards is a product that is refined, it's distributed, it's produced in areas where power plants already exist, which coincidentally is also the areas where populations already exist. And this is a small 50 megawatt plant that's going to produce about 48 million gallons a year, or about 3,200 barrels a day. So that's, in a nutshell, what T2E is working on. And it looks like we're close to our time frame, so I will conclude and thank everyone for being patient and listening, and turn it over to Denny, Max, and Ron.
All right. Thanks very much, Mark. It was very impressive. We had one question. I'm going to go ahead and address that to you, Mark, from our audience. They wanted to know if the technology was flexible for producing other oil profiles other than the C18, and also if the model that you've worked on, your business model, still seems to be profitable even if you would have to pay for CO2.
Well, the answer to the first question is we've been working for about the last 6 years on a specific strain of freshwater algae that's responded incredibly well to our growth enhancer. So one of the other products that we're working on is a saltwater based EPA-rich and a second saltwater algae, which is a DHA-rich algae for the omega oil market. So that's another very high profit line for us to pursue, and we're close to opening a 100,000 gallon facility that will be based in San Diego in the next couple of months. As far as specific profiles and what you're looking for, the answer is, there's over 1 million different strains of algae. So certainly, if it made financial sense and it was congruent with our overall pathway forward, then we would look at some other algal strains to produce different products. But where we're at right now, the C16 and C18 and teaming with Macarius gives us a very robust product line at a cost-competitive price with also virtually anywhere in the world.
Awesome. We also had an additional question for Stephanie. You still with us, Steph?
Sure am.
One of the questions was, is this a global issue with harmful algal blooms, and is this something that you've thought about marketing like to Asia or Europe or other markets?
The answer is most definitely, yes. In fact, China is one of the most algal bloom-ridden places in the world, and it even extends into climates where you might not expect algal blooms to occur. There are algal blooms that can occur under ice even. Red tides that you've probably heard of on the coast, those are algal blooms. So yes, it is an algal bloom. We have talked a lot about extending into overseas markets. There's a challenge there with the toxin products because they are regulated by the Department of Commerce. So we really don't understand if the overseas markets for those products are really big enough to justify trying to clear that regulatory barrier. Our other products, though, a lot of our management products and our fluorometers, for example, can be sold globally with virtually no regulation. And one nice thing about our products is they're all available on our e-commerce website. So we can sell those products overseas. We have not mounted a good effort yet, though, to market them overseas.
Thanks, Steph. We also had a brief question about what the capacity is of the Evidose equipment that you have for the centrifuge.
So capacity in terms of throughput, I'll give you a few numbers. So you can pump 750 liters per hour through the Type 10 unit, and recognize that that is the small, it's considered sort of the research grade unit. There's a Type 25 unit that is quite a bit larger, and I'm trying to remember what its capacity is. I have it here. And for what it's worth, these are all on our website as well. The Type 25 unit, you can run 4,000 liters per hour through.
4,000, as you said, liters per hour, right?
Correct, liters per hour. This,
awesome.
This technology is manufactured in Europe, so everything is, all the specs are in liters.
Awesome. We also had one additional question on the solid that is left over after you process the essentially the toxin portion.
Yes.
I think there's a suggestion there that it's used for fertilizers. Is that what's the characterization of that material?
That's actually a great interest of ours. We have characterized that material, but we certainly would suspect that it is very nitrogen and phosphorus rich. The challenge is it's also very variable. So we don't have the advantages that Mark has where he can control the content of his feedstock. So what we believe is that solid waste, and there is going to be a lot of it, probably be blended into something to make a household scale fertilizer of some sort. I don't think it's an agricultural type of scale, but definitely with nitrogen, phosphorus, and that could be recovered for a product. Definitely a way opportunity there. Someone try to experiment with that.
Awesome.
All right. We have one more question. This one's from Mark. The question really is, since you're getting the CO2 essentially for free off of the utility stacks, how much is your model dependent on that free CO2? And if you have to start getting charged for that in the future, how will that affect your business model of the $1 per gallon for the crude?
Well, I think it's an interesting question of, our business model is designed to eliminate that CO2 from flue gas streams. So I can't imagine a scenario in the foreseeable future where someone's going to charge us for that flue gas stream.
Sure.
Case in point there is one of the things that we think that our entire system will result in is best available control technology. So if we eliminate all of the particulate matter and we eliminate all of the flue or all of the contaminants, the greenhouse gas emissions, the metals, if all of that is being filtered through our system, and everyone has to get our system because EPA doesn't say what you have to do, they just say best available control technology, then I don't see a scenario where we would be charged for that CO2. But if we were, then obviously the dependent variable there would be how much are we being charged.
Right.
Awesome.
So in our case, if it's $27 a barrel to produce, and there's a zero cost for that 7% CO2 stream that's coming through the flue gas, what are they charging us?
Right. And I would also imagine that as long as the utility company would have to pay on their own to scrub that CO2 out of their system, they would probably be, not as dependent upon you to have to pay for that if you're providing a service to them for essentially free.
Correct. So, we're in negotiations with the power plant in Southern California now. They pay about $6 million a year as a carbon tax for their emissions. If we make that zero and then they can sell that credit somewhere else,
called a win-win, I believe.
That's a win. Yeah, that's a good business case.
Yeah.
That's awesome. All right, I'd like to thank our speakers, Dr. Stephanie Smith from Beagle Bioproducts and Mark Randall from T2 Energy for presenting this afternoon. It was absolutely awesome. We would also like to thank all of you who have stuck with us and joined us this afternoon as participants. We hope you will join us again for our next OBN event in March, which will be a webinar on the topic of funding impacts for the bioproducts industry related to the recently passed Farm Bill. This topic is in its initial planning stages, and the specific questions regarding it can be directed to Denny Hall for considerations as we're putting that webinar together. If you're not yet a member of the OBIC Bioproduct Network, I highly encourage you to visit our website, find out more, and download a membership application. Membership in the OBIC Bioproduct Network will ensure your access to great programming opportunities, such as our networking events and our annual meeting, and will keep you and your company at the forefront of happenings in the bioproducts industry. Again, I want to thank you for participating this afternoon, and we look forward to sharing time with you again in the future. Thank you.